I got two of them.
Is this going to be on the test?
No, it's just chapter 3. Okay, I had 2 copies of that open. I only want 1 copy open. Yeah, the test is just going to be over chapter 3. The review is posted up on eClass already. You can start working on that over the weekend if you want or if you have time. Review is on Monday, test is on Wednesday next week. And then we have chapter 7 and chapter 10, I believe, parts of chapter 10, and we're done. So we're pretty quick. Just a couple more weeks of lectures, another test, and then reviews for the final.
Interesting.
Yeah. Home stretch. You guys can do it, right? The answer is yes. Just in case you're wondering. Correct answer is yes. Okay, chapter 7, we're transitioning to solving 2 equations to unknowns, which is actually what we did at the end of chapter 3 in section 3.5. We solved, again, 2 equations to unknowns. But we're going to do that, in this case, for the most part, linear equations. Section 7.1 has a couple of homework problems that are not linear equations, but after that, they're all going to be linear equations. When I say linear, there'll be no exponents in them. It'll be just x's and y's, no exponents. So there are a few different possibilities that can happen here when you're solving your 2 equations to unknowns. You can have one solution. If you think about straight lines, your straight lines can cross in one point right here, and that gives you one solution to your equations. You can have more than one solution. That would be you have 2 lines, one right on top of the other, or you could have like a parabola with a line crossing through it, that type of thing, a quadratic with a line crossing through it. Or you can have no solutions. In other words, you could have parallel lines like that. You could have a parabola opening up here and the line going below it, that type of idea. Your graphs of your equations don't cross. So 3 things that can happen. They can cross in one point, they can cross in more than one point or an infinite number of points, or they could not cross at all. If they cross at more than one point, an infinite number of points, we call that a dependent system of equations if they cross at an infinite number of points. If they do not cross at all and they're straight lines, then we call them parallel lines. Okay, so the way this section looks is, the way this chapter looks is section 7.1, we're doing the method of substitution. That is a method that I taught you from section 3.5 for solving the equation we just did on the quiz. Section 7.2 is going to be the method of elimination. That method is actually a preferred method for most people. They like elimination better because you can solve it a little bit easier with less writing. And then sections 7.5 and 7.6 are going to be applications using these 2 methods. These applications are business applications. So those of you headed into business majors, these are your linear programming problems. These are problems that you do in business. And we're going to be doing that in section 7.6. Steps for the substitution method. You're going to solve one equation for one variable, plug it into your second equation, solve it for that second variable, plug it back into your first equation to solve for the first variable. So you're kind of going in a circle. Always check your answers, not because you have extraneous solutions, but because this is very easy to make mistakes on. If you're not checking your answers, you're not knowing whether you're getting your answer correct or not. There is absolutely no reason for me to have to grade any of your work from this section because you can check your answers to know whether it's correct or not. Okay? Just plug them back in and check. So let's start. We're going to start with a simple system. Solve this system of equations by substitution and check your solutions. So if I'm looking at these equations, what I'm going to do is I'm going to pick the equation that has a minus sign in it, and I'm going to solve it for the variable that is positive. So I have x minus y equals to 2. If If I add y to both sides, I get x is equal to y plus 2. There's no particular reason for me to do that, except I happen to not really care for minus signs that much. So I much prefer to keep things positive if I can. So solve this for x. Now I'm going to plug it into the second equation, which is x plus y equals to 4. I'm going to plug all of this in for x. That gives me y plus 2 plus y is equal to 4. Combine your y's together. What do you get? 2y. So 2y plus 2 is equal to 4. We're trying to solve it for y. What should we do? Subtract 2. And divide by 2, you have y is equal to 1. We solved for y. Now we're going to go back and plug it into either of the first equations. It doesn't matter, to solve it for x. Which one do you want to plug it into, the first or second equation? First equation, it doesn't matter. X plus 1 is equal to 4. Subtract the 1, you have x is equal to 3. So I think my solution should be 3 comma 1. We write it as x comma y. That is what we think the solution should be. Let's check it. And you have to check it in both of them, because it might work in one equation but not the other equation when you make the mistake. So for the first equation, 3 plus 1, is that equal to 4? Yes. For the second equation, 3 minus 1, is that equal to 2? Yes. So my answer is indeed 3 comma 1. Okay, the method of substitution. Any questions on that? Okay. This is where things get a little bit harder. We have a story problem. Most of you probably don't like story problems. I know I didn't when I was in algebra. A total of $12,000 is invested in 2 funds paying 5% and 3% simple interest. The yearly interest is $500. How much is invested at each rate? You know, the story part's not the hard part. The hard part is figuring out what the equation is based off of the story they give you. So they say the total is 12,000. When you see total, that pretty much tells you you're going to have to add something together to get to your total. I know I have 2 funds. One of them pays 5%, so the 5% rate we're going to call X amount invested in the 5% rate. The 3% rate, we're going to give that one the name Y. Y is amount invested in 3%. Now, it said simple interest. So simple interest is, yes. It's not e to the RT. It's just your principal times rate times time. Yeah, so this is going to be the amount that you're going to get. Principal times rate times time. So what we have to do is convert the rate into a decimal amount. And here our time t is just said, it said yearly interest, so it's 1 year. So now we have all of our information. If I have X amount at the 5% rate, P is the principal, so that's going to be X or Y. So at the 5% rate, we're going to have 0.05X times 1. And at the 3% rate, we're going to have 0.03 y times 1. Now this amount here is the interest. And they said we have a total of $500 in interest. So now I can set up my equations. X plus y, the amount at the 5% plus amount at 3% has to be the total of $12,000. You guys see that? X plus y, the amount invested has to be 12,000, and the interest has to be 500. The interest comes from the sum of these two equations over here, which is our 0.05x plus 0.03y. Here's my two equations, two unknowns. If they'd have just given that to us, we'd have solved it by now. But now we can solve it. Notice that these second ones have decimals on them. I don't know about you guys, but I don't like decimals any much better than I like negative numbers or fractions. So what I'm going to do is I'm going to multiply both sides of that equation by 100. I'm going to copy the first equation down, multiply the second by 100, so I get 5x plus 3y is equal to 500, and then 2 zeros on it. That gives me 50,000. Not 100%, by 100 to eliminate the decimals. Now I can solve this equation. There are no minus signs in this equation, so I get to choose whichever equation I want and whichever variable I want to solve for. So what is your desire? I'm not solving the first one. I'm going with the second equation. No decimals. You want to solve the first equation or the second equation? First one, what do you want to solve it for, x or y? X. So from the first equation, you have x plus y equals 12,000. Solve it for x. It's going to be 12,000 minus y. Now, what do I do? This is my first step. I'm going to substitute this back in to the second equation for x. So I have 5x plus 3y equals to 50,000. Plug this in for x. So we're going to have 12,000 minus y plus 3y is equal to 50,000. Solve that for y. What should we do? Multiply by 5, right? What's 5 times 12? 60. So we get 60,000 minus 5y plus 3y equals 50,000. What is minus 5y plus 3y? Negative 2y. So now I'm going to subtract my 60,000. And I have negative 2y is equal to what? Negative 10,000. What should y be equal to? 5,000. Positive or negative? Positive, because the two negative signs cancel. Now that we have our y equal to 5,000, how do I find x? Plug it in. It doesn't matter which one you plug it into, so plug it into one or the other equations. I'm going to choose the first one. That doesn't have a 3 times a y. It's easier to plug into. So x plus 5,000 is equal to 12,000. What does that tell you x is equal to? 7,000. So our answer should be 7,000 at 5%. And 5,000 at 3%. And you can check the answers. I'm going to skip it for right now because I'm going to run out of time. So we're going to skip it. You check it. It's your job now. Homework from the notes from the lecture. Yeah, you just plug it in and check it. Any questions on that? The hardest part with that problem is setting it up. We're going to get lots more practice setting up these equations. That's going to be in section 7.5 and 7.6. Okay, so now let's look at this one. Solve the system of equations. This one's going to have more than one solution to it. How do I know that? I have an x squared. Yeah. So I'm going to take the second equation because it's the simple one. And I'm going to solve the simple one for the variable that is not squared here, which means I'm going to solve it for y. So I have 2x minus y equals a negative 1. I'm going to subtract my 2x to the other side. And I have negative y is equal to negative 1 minus 2x. I want to solve for y, so what should I do? Divide by the negative 1. So I have y is equal to 1 plus 2x. This is my first step. The second step is to plug it back into the other equation. The other equation is 3x squared plus 4x minus y is equal to 7. All of that is going to go in for y. Now be very careful when you do this that you don't use this minus sign. So I'm going to put the y in parentheses. So I put parentheses around the 1 plus 2x because I have this minus right here that has to go with everything. So then I have to distribute that minus sign through that parentheses. And we have 3x squared plus 4x minus 1 minus 2x is equal to 7. What should we do next? Yeah, the 2x and the 4x. What does that give you? 2x, combine like terms. Now, how about that 7? Well, now I'm going to take them over to the same side. Yeah, so that we can factor. And now we're supposed to factor. If you don't see the factor, you can do the quadratic formula. I want to get an 8, and I want a difference of 2. That would be 12, so I need the 2 here and the 4 here. And I want it to be a plus 2, so that's plus and that's minus. I think that's correct. This gives me a minus 4x, that gives me a plus a 6x. When I combine that together, I should get a plus 2x. If that's equal to 0, then we have 3x minus 4 equals to 0 and x plus 2 equals to 0. From 3x minus 4, what is x equal to? 4 over 3. From x plus 2 equals to 0, what is x equal to? Negative 2. Now I have to plug both of these back in one at a time to find y. Which equation would you like to use to find y? The first or second one? Choose wisely, guys.
Find y.
Yeah, we have to find y. The second one. Yeah, it's easier than the first. I was teaching last summer and they chose the first one. Well, that's what I asked them. So I'm going to check for x equals to 4/3. If I plug that in for x, that means I have 8/3 minus y equals negative 1. Subtract 8/3. And I have minus y is equal to minus 1 minus 8/3. That minus 1 is like a minus 1 over 1, which can become a minus 3 over 3. And then you combine your numerator. Minus 3 minus 8 is a minus 11. So minus y is equal to minus 11/3. What is y equal to? Positive 11/3. So that gives us the solution 4/3 and 11/3. That's one solution. And then we have to look at x equals a negative 2. 2 times negative 2 minus y equals a negative 1. What is 2 times negative 2? Negative 4. Add the 4. And you get minus y is equal to 3. What is y equal to? Negative 3. So then that gives us a -2, -3. And of course, you check both in both equations. Yep, and you're going to check it. I'm circling the wrong thing for my answers. Here's the answers, and here's the answers. We have two solutions here. Now, I know what's going to happen. You guys are going to use WebAssign to check your answers, because if WebAssign's happy, then you know it's correct. But on the test, at least do me the favor of checking those answers when we come to that test, because you don't know how many times I mark it wrong. It's like, well, if you'd have checked it, you'd have known it was wrong and would have fixed it. So check them on the test. One person did do that, but that's one out of, I don't know, I've been teaching now 17 years. So one person checked it wrong, and I could see where they plugged it in wrong and got the wrong answer, and they did the work like 3 times and kept getting the same answer, and they finally left it, and they had the right answer. But when they plugged it in wrong. But that's only happened once in 17 years, so that's not likely to happen. No. No. If you have the right answer and you make a mistake in checking it, I don't take points off. However, if you have the wrong answer and you check it wrong and you didn't fix it, then I take points off. Yeah. Okay, so any other questions on that? 2 solution case. Okay, so let's skip the checkpoint. I want to do one more. It's a no solution case. This one's actually really important. We have to do this one. Solve the system of equations. Notice right here I have a minus x plus y equals 4, and then I have an x squared plus y equals to 3. So which one should we solve? The first equation or the second equation? First. And what variable do you want to solve it for? I'm either going to have an x equals or a y equals. So I'm going to add the x to the other side. And my x became a 4 today. It is Friday. Problem is I've been making those kinds of mistakes all week. It hasn't been Friday all week. My problem this week is that on Wednesday I was convinced it was Thursday, and on Tuesday I was convinced that it was Wednesday. So I've been a day off since the beginning of the week. So we have y equals x plus 4. Plug this in for the y variable right here. And we're going to have x squared plus x plus 4 equals to 3. So subtract our 3, and you get x squared plus x plus 1 is equal to 0. I know I can't factor that, so let's go straight to the quadratic formula. That's minus 1 plus or minus the square root of b squared, which is 1, minus 4 times a is 1 times c is 1, all over 2 times 1. So let's simplify. What's a 1 squared? 1. 4 times 1 times 1? 4. 1 minus 4. Is that a real value? No. This is imaginary. I'm only looking for real solutions here, so there's no solution. I was looking for real solutions. In this case, there's no solution. Okay. There's another time when you can get no solutions. If you're working through and you get something like 0 equals to 1, this is also a no solution case. Okay, so you can have more than one way of getting no solution. I got it because my quadratic formula couldn't be solved in the real numbers. You can also get a false statement. 0 equals 1, 10 equals 2, something false like that. That tells you that is also no solution. Okay, so I need to tell you how to solve this one, and then we'll be done. This one has fractions. We've done one with decimals. Now we're going to do one with fractions. I personally don't like fractions, so what I do is I find my denominators here and I multiply everything by both denominators. So I have a denominator of 5 and a denominator of 2. I'm going to multiply everything by 2 times 5. It looks like a 2.5. This is a 2 times a 5 times a 1/2 y equals 2 times 5 times 8. So this 5 and that 5 cancel, and you're left with a 2x. Over here, the 2's are going to cancel, and you're left with a 5y. And then here you have 2 times 5 is 10, 10 times 8 is 80. So you get 2x plus 5y plus 80, and your second equation stays the same. So let me rewrite them. Yeah, and this is the system we solve. So we really want to solve that second equation because that's the easy one. What do you want to solve it for, x or y? Do you want an x equals or a y equals? X equals. So we'll take the y over. X equals 20 minus y. It really doesn't matter. Other than you have a 2 here instead of a 5. Makes it a little bit easier. Plug it back into that first equation. So you're going to have 2x plus 5y equals 80. You're going to have 2 times 20 minus y plus 5y is equal to 80. What's 2 times 20? 40. So 40 minus 2y plus 5y is equal to 80. Minus 2y plus 5y. 3y plus 3y equals 80. Subtract the 40. Yep. 3y equals to 40. So y is equal to 40 over 3. Unfortunately, that fraction I have to keep. Plug it back into the second equation because that's the easy one. So I have x plus 40 over 3 is equal to 20. I choose not to have decimals because they're imprecise. Most of you guys weren't alive for the first Gulf War, but we shot down we shot a missile over there from a boat, and it missed the complex. They're guided missiles, so they're very precise, but it missed the complex it was aimed for and got a building right next to it, which was a hotel or a school or something like that. So it got civilians. And the reason it was off was because of the computer programming inability to round conversion from base 10 to binary. It was a decimal error. How many decimals did the programmers need to carry? They didn't carry enough decimals. I'm loath on decimals. Yep. People died because someone rounded. It does sound terrible, but that's exactly what happened. So this becomes 20 over 3. You have your answer.
That was a good ending to the week.
That was, sorry.
That's what I learned.
I learned in my math class that people died because someone rounded. It's true. Okay, make sure your names are on your quizzes and your quizzes are up here. We're done for today.